Hi, my name is Gökhan Varol, and this is the first of my series SQL tips. This is about data auditing with cross-apply and table constructor. This is strictly about SQL Server, and this is gonna explain a little bit of how to use a trigger to data audit. A trigger is something that will get fired on a data modification on a table, on a view in SQL Server, and there are performance implications with enhanced trigger usage. The example I'm going to show here is something I have used, but after scaling up I had to get rid of from some of our systems because of triggers are not as scalable as I wanted them to be, and they require quite a bit of work done by SQL Server. But for a system probably a couple 100 GB of size, it's possible this can be a solution for a while. And what a table constructor is, if you look at here, this is called a table constructor. It defines a values clause. It's common in the insert statements that comma delimited list of items, and then within a parenthesis, meaning within a parenthesis, and then that can be also repeated for each row, and then it can represent the column list we specify. This is a copy of like my section of production product table in AdventureWorks, but if I kind of run that, you will see that it's basically storing the data textually. Okay, and this is a simple use of it. Now I'm gonna use our tempdb database so that next time on a restart that will be flushed. I don't have to worry about cleaning the tables. I'm gonna create a product table. I'm not gonna use identity column, there is no need for it in this example. And then I'm gonna insert into the product table the same data we seen a little bit earlier, like 10 rows. Now I'm gonna create an audit schema to put my audit related tables in this single schema. And what I wanted to do is, like for DML modifications, I want to store changes of the data. And then as I do that, I also want to store like some information about who changed it, like from which server name, when the change was made, from which program name, and as which login name, right? This is gonna store that and also give me a transaction ID. We'll get to that in a second. And then I'm gonna create an audit table for the product table. Since product ID is a primary key, I'm not gonna repeat that. That's gonna be my also primary key on the audit table with a transaction ID column. And then the transaction type I'm gonna put there. This could have been maybe bypassed, but I think it's cleaner with it. It can be a delete or insert and update. D for delete, I for insert, U for update. And I'm gonna store the column name because we are gonna pivot the data, and then the column name gonna be the line item. And then I'm gonna store the before value of the column and after value. Of course, in an insert trigger, we are not gonna have a before value, but only after value. In a delete trigger, we only gonna have before value. In an update trigger, we're gonna have both, because update can have before and after. And I'm gonna put a primary key on transaction ID that we're gonna get from the first table, product ID, and then the column name, because for that product the columns can be repeated also. Now for insert trigger, what are we gonna do is we're gonna define a trigger on product table. The trigger can be defined on a table or a view, and I believe that's about it. And I'm gonna specify for insert. I could have combined all the triggers. All three triggers I was gonna show in the sample here as update and delete. That this trigger will fire always, but I decided to have them separate. Looks cleaner to me like that. And this is an after trigger. In SQL Server there's also instead of triggers, meaning instead of is whatever modifications was about to be done in SQL Server, the instead of trigger, when it gets fired, it has to handle all the transactions or nothing gonna happen. But this is an after trigger, meaning something did happen. We can roll back from the trigger if you wanted to. If you roll back, the originated transaction will also roll back. We have that option here, but regardless, this is afterwards, right after the primary key constraints are checked and everything like that. I'm gonna put a shortcut here. If, like for example, if an like not for, I cannot think for an insert, but if table A set I, if somebody were to update table A with this way, and the table A had a trigger on it, an update trigger for example, trigger will get fired, but of course the row count gonna be 0, right? In a row count 0, I do not want to create transactions and I do not want to actually do anything. That's why I want to basically skip it at the first site. But the row count, this line has to be first thing right after as, because I made a mistake earlier. I typed it this way and the row count is always 0 because it's getting the row count from this statement. Therefore, please, if you use that shortcut, make sure it's always the first item, right? Then we're gonna create the transaction ID, basically, right? Basically, this is the host name, program name, login name. The date added was like a default of the get date, and then we can basically output that value. It will be incremented because everything we did will be logged into the audit table, right? Anyway, the trigger started. For insert trigger, we're gonna insert the transaction ID, our product ID. Look, by the way, the inserted table is only the data affected by that insert statement. Of course, includes all columns, even though only one column inserted into a table, it will include the exact table definition column-wise, like number of columns always going to be matching the table. And that table will be available to us in an insert trigger. That the deleted table is going to be available to us in a delete trigger, and both will be available to us in an update trigger. But for an inserted trigger, there's no delete table. Therefore, like I'm going to check the inserted table. And look at this right now. This is our definition. The definition, the data we're gonna insert into transaction ID, product ID, transaction type, and then column name, and after value. Okay, this is like a script we created, right? The column name in this case is name. After value is name column from the product, and then we have a flag here. If the what I did is, like for this on an insert or delete, if the data was numeric, I check only non-zero values I'm inserting into the trigger, and for strings only non-blank values, and for the rest only not null values, right? And I'm gonna get to that very shortly. Here you see it's creating a flag, changed flag, and then after defining the table constructor, it's checking if anything changed, and then only and only that it's gonna insert into the table. Okay, yeah, that can seems cumbersome, that can cause to mistakes, because like if the table has 200 columns, who's gonna deal with that? I mean, I have basically what we can do. We can get the table definition for product table from syscolumns, and I also needed to get the type information, meaning that the type information is basically the type names, and then the user type ID is stored in the columns anyway. I'm gonna link user type ID to the syscolumns, right? And then let's look at the single item here, put it on top. Right, now we are generating this script here. That's the name as over here, and then remember I mentioned something here. If it is character, the data type is character, type name is character, or type name is system name, I'm gonna leave it as it is, because for the rest of the columns I need to cast them into a string, because our audit table stores them as a varchar 8000. For the rest, I'm gonna do a casting to varchar 8000. That's this section. And then over here, if the data type is numeric, so then this key is gonna run. This key is gonna say, this is dynamic script again. If the value is not 0, then 1 as 0. If the type name is character or sysname, we're gonna check against single, like blank string. And other than that, we're gonna check if it's not null or not. Basically, this will create, make sure we are in the same database, which is we are. Okay, let me change it to text. This will create that whole script we have. Right? I mean, there is no limit on how much we can customize. I mean, I have created scripts that create all those triggers for all the tables in all database, considering finding out multi-column primary keys and then put them as multi-items. Like, just, you can customize it. That's awesome. Like, that's SQL Server, right? Anything dynamic you can create. Basically, this is our insert trigger. Okay. And then the delete trigger is very, very similar, except of course for delete on the same table, right? And then we're gonna have this as D, and instead of after value, we're gonna create an insert value, right? The rest is like, this is just a little bit different formatted, no need to worry about it. And then the update trigger, of course, is a little bit more work. We get the still transaction ID, we define it as update. Of course, in the update trigger, what we do is we have a before value and after value. Now our changed, to get the change, we compare deleted and inserted, we join them by the primary key, right? And then this is what we check here. For example, for each column, if the column identical or both left and right side before and after is null, then there is nothing changed, else something changed. Therefore, we also filter by the changed. Right? This is also like I'm gonna post this. This is also like a generated script. You're gonna be able to access that. This is actually easier to generate. And then, okay, let's create that. Now, let's see what happened, right? I'm gonna roll it back so that I can keep repeating this issue. I'm gonna update two records, the list price and standard cost, and then get the data from audit table and roll it back, right? This is stored as a different table for each transaction. Just this is left join, therefore, like, we don't have to worry about this is a lot of data. This is not a lot of data. Basically, each transaction of ours, if you notice, had 10 records, because we updated like without even a var clause. There's 10 records in the table, and then store the column names and standard cost. Actually, let's do that. Let's combine that. Okay, let's hide that. If we were to do it like that, I guess. Good. Now, single transaction created 20 records because one for each column, right? And then if we were to modify them identical to the same value, nothing would have changed. Like, for example, if we were to do this, right? If we were to modify them to itself, now we are only going to have 10 records because we didn't modify the standard cost. Therefore, it can generate quite a bit records, as you can imagine. I mean, for what it does, it's probably efficient, but by no means a trigger and inserting into a table like from simultaneous hundreds of connections may not be the idea. Okay, let's do the delete one. Delete, of course, creates a record for every column deleted which are not null or non-zero. And basically, we might prefer for deletes and inserts, we just want to have a different table, has as many columns as a table, and then for updates, we're gonna have before and after images. We can decide what to do with it, because this might be too many records, or we may not have too many deletes anyway. Therefore, this is not important for deletes. For inserts, we might consider something, because we might have a lot of inserts. Maybe we won't log the create an audit record for inserts. Like, it's all up to us. We can do whatever we like to handle this, right? And then this is basically for an insert, right? I'm inserting more records, same data set, but I'm changing the product ID. And this is the inserts, right? Notice, like, there is no nulls be stored in the insert. That was on purpose. And this is if you combine all of them in a single transaction. Yeah, so I'll post this scripts also, and hope this will be helpful. Okay, thank you.